So we're going to learn more properties of systems by examining this system graphically. So to graph, I'm just going to label this equation 1 and this equation 2 so I can work down here. I want to isolate y so that I can look at y equals mx plus b4. So I get y is equal to, I'm moving this over, negative 2x minus 1. So let's graph that. My b is my y-intercept. My slope is negative 2, so I'm going to count down 2, right 1, down 2, right 1, down 2, right 1. I'm going to go in both directions. I'm going to go up 2 and left to keep that pattern going. I like to draw lots of points just to make it easy to graph this line here. So we're going to do that and put arrowheads. Okay, let's look at equation 2 now. So I want to isolate y, so I'm going to get 2y. I'm going to move this 4x over, so it becomes negative 4x minus 2. Now I'm going to divide off the 2. Y is going to equal to negative 2x minus 1. And if you have a look, this ended up being the same equation. So of course, graphing it, I would get the same line. So if you have the same equations, therefore, it's the same line. So I might kind of want to just show that, I graphed it twice or something like that. So if you have the same line, one line right over top, that means it intersects technically on every single possible point, not just the ones I plotted, but all of these points in between, okay? So same lines are called coincident lines. So we're going to just write that down. So these are called coincident lines. So some new terminology for us. Okay, and coincident lines, we would say in math that the solution is every single possible thing and it goes on and on and on forever. It comes from the word infinity, which means it's going to the negative values forever and the positive values. So we would say there are infinite solutions, or sometimes we say infinitely many solutions, but we would say infinite solutions. So when you end up having the same line and your equations end up being the same line, then you don't necessarily need to even graph that. You know that you have infinite solutions.